Hello boys and girls, and welcome to lesson 3-6, types of triangle. Let's get right into it. Page 75 of your math journal. For number 1, we are asked, we're first shown what an equilateral triangle looks like. Equilateral triangles. This would be it. And what they do not look like. Not equilateral triangles, such as these ones. Equilateral triangle. Well, take a look. This one is 5. The distance is 5 units. The distance is 5 units and 5 units. These were not given the units, but these little, sticks or these little lines that they do there, these little dashes, this means that if this one has 2, and this one has 2, and this one has 2, that they're all equal. They're all the same. So, all 3 sides are the same, and all 3 sides are the same. Let's look at the ones that are not equilateral. This one's different because it only has 1, so it's one of its own. This one has 2, and this one has 2. So you can tell that this one and this one are the same length, but this one is a different length. This one's 6, 8, and 10, different, and these are all probably the same length, but it's not a triangle. Okay, so an equilateral triangle must have all sides equal. Write a definition for an equilateral triangle. Simply put, we can say an equilateral triangle is a triangle in which all 3 sides are equal in length. Go ahead and copy this down. Question 2. An isosceles triangle. When we talk about isosceles, we're actually look at the word iso. Iso means on its own, one. Okay? We have here a triangle, and you can see that these 2 sides are equal because they have the same label, the same 2 dashes. But this one only has 1. This one stands alone. It's isolated. Likewise here, 7, 7, and the 12's alone. Okay, over here we have 2 and 2, and the 1 is alone. And on this one, all 3 are the same. Okay, so an isosceles triangle can also be an equilateral. But an equilateral, all equilaterals are not isosceles. These are not isosceles triangles. This is different from this one and from this one. This one's different from this one and from this one. So write a definition for an isosceles triangle. You can see that you have 2 sides that are the same and one is a different length. 2 the same, 1 different, 2 the same, 1 different, or all 3 could be the same. But at least 2 sides have to be the same, at least 2. A good answer would be an isosceles triangle is a triangle in which at least 2 of the sides are equal in length. Go ahead and copy that down, and then we'll do number 3. Number 3, scaling triangles. Take a look at the images of this side of what constitutes as a scaling triangle and what is not a scaling triangle. As you can see over here, by the markings, we have 3 lines, 2 lines, and 1 line. This indicates that all 3 lines are different lengths. On this side we have 2, 1.5, and 2.25. Over here we have 15, 16, and 4. Okay, so all 3 sides are all different lengths. Not scaling triangles, this one has all 3 the same. So this could be a equilateral or an isosceles. This can also be an equilateral or an isosceles, and this one can only be an isosceles because it has 2. So, how would you best define a scaling triangle? Go ahead and try to write a definition, and I'll write mine in just a minute. You can pause the video now. A scaling triangle is a triangle in which no 2 sides are the same length. Go ahead and copy that down, boys and girls. And we'll move on to page 76. For page 76, I have a little surprise for you, boys and girls. Here with me today, I have Mr. Elliot.
How you doing?
Ready to show you the ropes. So let's turn to page 76 and get started. Copying triangles.
Alright, so it says here, if two triangles are identical, meaning exactly the same shape and size, they are congruent to each other. Congruent triangles would match perfectly if you could move one on top of the other.
Okay, so essentially, to make a congruent triangle, we have to measure all three lengths to our triangle and the angles. So we'll start with the baseline. Our baseline is from 0 to about 6, I'm going to say 6.1 centimeters. So we will draw our baseline here from 0 to 6.1. Okay? And then I need to figure out how long our next line is. And it's exactly, as you can see, from 0 to just before 5. And you have to be as exact as possible. So we have, from 0 to 5. But before I draw that 5 centimeter line, I have to figure out the angle so that I know where exactly I'm going to draw it. So I align the baseline with the baseline on the protractor and the vertex of the protractor with the corner of our triangle. Like so. So then I follow my line and I see that it is 70 degrees. Okay, remember we are counting from 0, 10, 20, 30, 40, 50, 60, 70 until we get to 90 and then it goes above 100. So right now we're at 70 degrees right there. So I'll do the same thing here. I'll match it to the end of the line with 0, find 70, put a dot right there, and now I'm going to draw my 5 centimeter line. From 0 to, it's got to match the little dot I made there so that I get the right angle, to 5. And I've just successfully drawn my second line. As you can see, we have this line and the baseline drawn almost exactly. I could take this part and fit it right in there like a puzzle piece. But now we need to draw this line over here that's on an angle. Before we can draw it, we first need to check the length of it in centimeters. So let's match it from 0 right there. And it looks like it's 6.5. Nice and easy number to work with. So you see that there is the 6 and there's the half mark. So it's 6.5. So I'm just going to remember that by making a note on the side. And now I want to measure the angle. The angle from this line or from this line. I'll work with the bottom line. The baseline is always easiest for me. Okay? Measure from right from the center there, the bottom. And you will see that 0 is along the line here, and it follows about a 46 or 47 degree angle. I hope that's right, but it looks like it's about 46. Okay, so if I do that down here, I match it exactly, and I go right to 46. It should match, and there it is. It matches exactly. So now all I have to do is just make sure that the length is correct from there, exactly 6.5. And there is our triangle. Now, bonus question. P, let's label it. Well, actually, P-A-L. Okay, what kind of triangle is this? If you notice, we have 6 here, 5 here, centimeters, sorry, and 6.5 centimeters there. All three are different. So we could say that this is 6, this is 5 centimeters, and this one is 6.5. I made a little mistake now. I'm sure you guys caught it. That this one is 1, this will be 2, and this will be 3, because they're all 3 different lengths. When a triangle is all 3 different lengths, what do we call it? Scaling triangle. And there we go, boys and girls. This will be your key answer. Make sure to put a star there and a star there when you complete it, and we'll know that you watched this video.
Hi there, boys and girls. Now we're going to take a look at page 77 in your books. This page is called Copying More Triangles. And it's a little bit more interesting than the last page in the fact that it's going to start asking you to try to trace these triangles, make congruent triangles without using certain tools. In the first question, letter A, it says measure the sides of the triangle HOT in centimeters. Write the lengths next to the sides. In that case, you're going to take your ruler out and you're going to measure one side and put in the answer. Then you're going to do the same thing with the other two sides and mark them next to those sides. Then when we follow it down to part B, it says, make a careful copy of a triangle HOT on a blank sheet of paper. You may use any tools except your protractor. Do not trace the triangle. When you are satisfied with your work, cut it out and tape it in the space below the triangle, HOT. So right about here should do. Label the vertices R, E, and D. Give that a try, and we'll check it out next time in class. Take care, boys and girls.